Good morning, I am Santosh Kumar Bhandare. I am working as an assistant professor in CSE Data Science at R.C. Patel Institute of Technology, Sherpur. Today I am going to teach binary searching. These are the vision and mission of our institute. Design and analysis of algorithm. The prerequisite for this subject is computer programming and knowledge of data structure. And the course objective of this subject is to provide mathematical approach for analysis of algorithm, to introduce important algorithm design, paradigm and approaches for effective problem solving, to introduce the concept of traceable and intractable problem and the class P, NP and NP complete problem. These are the course outcome of design and analysis of algorithm. The first CO1 analyze the performance of algorithm by solving recurrence relation with various methods. CO2 solve the problem using appropriate algorithmic design technique. CO3 demonstrate that certain problem are NP complete. In this unit, a student will learn method for solving recurrence relation using tree substitution master method, problem solving using divide and conquer algorithm, in which they learn binary search, quickshot, merge sort, randomized quickshot. This is the advanced version of quickshot, analysis of binary search, quickshot and merge sort. So today we will try to learn binary searching, how binary search work. So what is binary searching? Binary search is an efficient algorithm for finding a target value in a sorted array or list. Instead of checking every element one by one, it repeatedly divides the search range in half. The essential condition for this algorithm is the data must be in sorted order. So how it work? Number one step, start with the entire sorted array. Step number two, find the middle element. And how we will find the middle element? We will calculate it using formula lower bound plus upper bound divided by 2. Third one, compare the middle element with the target. Here we have three cases. If the middle element equal to the search element, then the search is completed, means we can find the element. But if the middle element is not equal to the search key, then we have two cases. If the target is smaller, case 1, the target is smaller, then search the left half if the target is smaller. If the target is larger than the middle element, then we will definitely find this element to the right of middle element, that is search the right half. Step number 4, repeat until the target is found or the search range is empty. This is the time and space complexity. In base case, the time complexity is big O1, that is constant time. In average inverse case, the time complexity of this algorithm is big O log of n. We can implement this algorithm using two approaches, iterative binary searching and recursive binary searching. So here we take one example. Here we have an array consisting of 7 elements, and the index of this array range from 0 to 6. In step number 1, first of all find the middle element. Who is the middle element? So we will calculate it using lower bound plus upper bound divided by 2. Here we have 0 as a lower bound and 6 as a upper bound. So 0 plus 6 divided by 2 is 3. So the value at index 3rd is the middle element, and we will compare it with the target value, which is 25. Here 25 is greater than 18, means we discard the left part of it and continue searching on the right half. So in this case the lower bound become 4 and the upper bound become 6. So in the second iteration of this algorithm, again calculate the middle element. Here the lower bound is 4 plus 6, that is 10 divided by 2 equal to So in step 2, the lower bound become 4 and upper bound become 6, and the mid equal to 4 plus 6 divided by 2, that is 5. So the element at 5, which is 31, and which is lesser than the 25. So the target value 25 is lesser than the mid element. So we can discard the right part of it and search in the left half. So who is the middle element? That is 5. So who is the left of it? We will see in the third step. So in third step, the lower bound is 4 as well as higher bound is also 4, and the mid element is 4 plus 4 divided by 2 equals to 4, and at index 4 we have 25. At this time in step number 3 we got 25 as index number at index number 4, which is equal to the target key. So we simply print that the target value found at index 4. This is the summary of binary searching. In the first iteration the middle element is 18, and second iteration the middle element is 31, and the third iteration the middle element is 25, which is the target value. And this is the short description of the algorithm. Here we set low equal to 0, high equal to n minus 1. What is n? N is the number of element in the array. Find middle element using low plus high divided by 2. Here we have 3 cases. If key equal to array mid, then return mid. Otherwise we will search either in left subarray or right subarray. If key is less than a of mid, then search left half. If key greater than a of mid, then search right half. Repeat until found or low greater than high. If low greater than high and we cannot find the element, then the condition, then we exit from the algorithm. The time complexity is big O log n. This is the iterative method of implementing binary search. Here the first line shows the name of the method, that is binary search. Here we pass 3 values, array, n number of element, int x is the target value, these are the two variable low and high. Low initialized with 0, high initialized with n-1, and this is the while condition where low is less than equal to high. We will continue the steps. Initially calculate the mid, which is equal to low plus high minus low divided by 2. We can also use this formula. We can also use low plus high divided by 2. Here we mentioned three conditions. If array mid equal to x, then return mid. If array mid is less than x, so in this case we modify the value of lower bound, which is equal to mid plus 1. Otherwise high equals to mid minus 1, and after the while loop we return minus 1, that is we didn't find the element. This is the recursive method to implement the same thing. Here we pass different parameter, array, lower bound, upper bound, and the target key. First of all, calculate the mid value with the same formula. Then inside after that, if the array mid equal to x, then return mid. Simply we found the element. If it is false, then we have two more cases. This is the first case where array of mid greater than x. Array of mid is greater than x means the value at mid is greater than the target value. So in this case we recursively search the target key in the left subarray. So here we write the statement return binary search array low mid minus 1 x. Similarly, if this condition is false, then definitely the element is found to the right of the subarray. In this case, we simply modify the parameter array, the name of array, comma mid plus 1, comma high, and x. If after exit from the if statement, we simply return minus 1, which indicate element not found. Course content taught with CO2. Solve the problem using appropriate algorithmic design technique. This is the reference. Thank you.